Hello guys, are you ready for our new discussion? Today we are going to tackle all about reference angles. And our learning competency is we're going to use reference angles to find the exact values of our circular functions. Now, let us define what is a reference angle. Okay, reference angle is said to be the positive acute angle that can represent an angle of any measure. So take note again of this property of a reference angle. It should always be a positive and it is said to be an acute angle. Okay? And then of course, another definition is the smallest angle that the terminal side of a given angle makes with the x-axis. So another identity of a reference angle is that it should always be the terminal side would be on the x-axis. Okay. And then of course, a while ago from the very first definition, okay, it must be less than 90 degrees, and in radian measure it should be less than pi over 2. And of course it uses the x-axis as its frame of reference. Okay, let's take an example. Okay, we have here the given measurement in quadrant 1. To identify the measurement of the reference angle is the angle itself. In quadrant 2, the given measurement is 180 degrees minus given angle measurement. So we have there 36 degrees. In quadrant 3, the given measurement minus 180 degrees is, of course, that would be your reference angle. And of course, on the other hand, on your quadrant 4, the 360 degrees minus the given angle measurement. That is now your reference angle. So again, we have here the signs of the coordinates of your point theta depends on the quadrant of or axis where it terminates. The signs of cosecant, secant, and cotangent are the same as sine, cosine, and tangent respectively. So as you notice on our Cartesian coordinate system here in quadrant 1, all functions are said to be positive. Quadrant 2, sine and cosecant are said to be positive. Quadrant 3, tangent and cotangent are positive. And of course, quadrant 4, cosine and secant are said to be positive. Okay. Now, another thing to consider in using this reference angle is that it would be of great help to us if we are familiar with the unit circle, with the corresponding coordinates. So that's why I require, or maybe may I ask that you would be memorizing this unit circle with its corresponding angle measurement in degrees and in radian measure, and of course the different coordinates of them. Okay, let's try an example. The first example here, guys, is determine the reference angle and the quadrant where it lies, an appropriate sign to find the exact value of sine 11 pi over 6 and cosine 11 pi over 6. So again, you're asked here for the reference angle, then where the quadrant where it lies, and of course the appropriate sign of your exact value. Okay, so our solution would be the reference angle of 11 pi over 6 is pi over 6. So you're going to show that later. And it lies in quadrant 4, wherein sine and cosine are negative and positive respectively. So again, it's in quadrant 4. So your x-axis is positive, your y-axis is negative. So take a look on our sketch of the angle. Okay, so we have here, of course, your 11 pi over 6. So you notice from the definition of the reference angle, it should have what? Less than 90 degrees or acute angle. Okay, so by this example, our reference angle is pi over 6. And take note, our answer a while ago is in quadrant 4. So our angle is said to be in quadrant 4 from the counterclockwise direction. Then of course, if it's 11 pi over 6, recall from our unit circle what would be the coordinates of that. We have square root of 3 over 2 and of course negative 1/2. So therefore, if we would determine the reference angle and then the exact value of that of sine 11 pi over 6 is simply negative sine pi over 6. Okay? Because we all know that in the quadrant 4, sine is said to be negative. And of course, what? The value of that is, sine is with respect to y coordinates. So therefore, it's negative 1/2 as it says here in our coordinates. Okay, on the other hand, cosine 11 pi over 6 is said to be cosine pi over 6 with respect to its reference angle. And of course, the value of cosine is simply its x coordinate. So x square root of 3 over 2. So there you have it, guys. So again, that's how we determine the reference angle given in radian measure. Let's sketch it first, and of course identify the quadrant, and considering the signs of your trigo functions, and of course your coordinates. Let's have another example. Our second example here is you are asked to determine once again the reference angle, and then of course the quadrant where it lies, and then appropriate sign to find the exact value of cosine negative 7 pi over 6. So if we sketch the angle which is negative 7 pi over 6, it is said to be a clockwise direction because it is negative. So therefore, our angle lies, negative pi over 6 lies in quadrant 2. And wherein cosine is negative and its reference angle is simply pi over 6. Okay, let's take a look on the sketch of the angle. So there you have, it's clockwise because it's negative 7 pi over 6. So if it's negative, therefore its reference angle is pi over 6. And then of course recall our coordinates. It is said to be in negative square root of 3 over 2 and 1/2. So that you are asked here for the cosine. So the reference angle is negative cosine pi over 6. And then of course your exact value is simply negative square root of 3 over 2. The value of your x coordinate in your coordinates of your 7 pi over 6. Okay, so that is how we determine the reference angle. So let's generalize or sum up our discussion, very short discussion today. We have the reference angle. Again, take note, it is the smallest positive acute angle that can represent an angle in any measure, whether in degrees or in radian. And then of course, it uses the x-axis as its reference or frame of reference. Okay, and then of course, for the trigonometric functions, bear in mind in our quadrants. Okay, in quadrant 1, you notice there that we have all the functions are said to be positive. Okay, so that is, guys. Thank you for listening, and again, hoping you have learned something today from our discussion. Thank you, guys, and God bless. See you again on our next discussions.